Hello and welcome to the third and final video for today. This particular video is quite a bit different than the first two in that we are actually doing some geometric, almost a geometric proof. We're almost to the point where we can look at doing geometry proofs and telling whether certain things are true, making conjectures and those kinds of things. And the main topic that we're looking at today, this is brand new for us, so I would definitely write it down on your notes sheet that you've been given, is that corresponding parts of congruent triangles are congruent. And that seems like a very obvious thing to state, that if you have two congruent triangles, that all 6 parts on the first triangle are going to be congruent or have a corresponding congruent part on the second triangle. It seems almost silly to state, and one of the things that we've discovered about geometry is that we are constantly having to state the obvious, and this is no exception. We actually have to state the obvious. If we find 2 congruent triangles, we actually have to say all of the parts on the first triangle are congruent to all of the parts on the second triangle. So let's kind of tackle this. We are being asked to make a conjecture today based on some information that is being given. Okay, so let's look at the statements that we have been given first. First of all, we are being given the statement that angle KJL is congruent to angle KJM. So let's find those and mark them. It always helps to be very diligent about stating what you know so that you can visually see what's going on. All right, so let's find angle KJL first of all. Angle KJL is right here. That's this guy right here. Okay. He is congruent to angle KJM. So KJM, that's this angle right here. So let's draw a little arc right there. Not a very pretty arc, but it's an arc. All right, so those 2 angles are congruent to each other. Okay, well, it looks like I have the potential of some kind of angle theorem going on that we can use to prove that these 2 triangles are congruent to one another. Let's see what other information we have so that we can continue. I'm going to change pen color. We're looking at here, it says line segment JL is congruent to line segment JM. So JL is this guy right here, so let's mark him with a tick mark. And line segment JM is right here, JM, so let's mark him with a tick mark. Okay? All right, so I see an angle and a side on one triangle and an angle and a side on another triangle. And that I see a lot of potential there, because if we can prove that these 2 triangles are congruent, there's a whole other storm of information that we can find about these 2 triangles. Okay, so let's kind of take a look at what we're being asked here. The conjecture is that line segment JK bisects angle MKL. So here we have line segment JK, and we're being told, or we're wondering, if it is bisecting MKL. So we have a larger angle here with MKL, and we're wondering if JK is bisecting that angle. And what bisect means is to cut something in half equally. Okay, so that would have to mean that angle MKJ, this little tiny angle in here, would have to be congruent to angle JKL, the other little angle that is formed. So there are 2 little smaller angles that are formed. And our goal would be to figure out that those 2 angles are congruent. If we can do that, then we are proving that this conjecture is correct. Well, therefore I want these 2 triangles to be congruent to each other somehow, so then I can say that that angle is indeed congruent to that angle. And all I have right now is a side and an angle on the first triangle and a side and an angle on the second triangle. But I am noticing that JK is that included side. Okay, it's actually a side that is shared by both triangles. So I can, using that reflexive property that we talked about later last week, we can say that we have another side of each triangle that is congruent. And I'm going to mark that with 2 tick marks because of the reflexive property of congruence. Okay, so now I see I have a side, and I have an angle, and I have a side. And luckily that angle is inside of those 2, that angle is inside of those 2 sides. So I actually can prove that these 2 triangles, triangle JMK, and triangle JLK are congruent with the side angle side theorem. So I have side angle side here, and I have side angle side here. So here's the argument that we need to make. We need to make the argument that because these two triangles are congruent, therefore the corresponding angle here, and let's get a different color still, we'll use purple, this angle right here would also be congruent to that angle right there. Okay, so let's actually state this. What kinds of words do we actually need to use in order to make this argument? Okay, first of all, I'm going to say yes, they are congruent. All right, yes, the angles are congruent. Okay, why are they congruent? Well, because I am able to prove that the triangles are congruent using side angle side. Okay, and doing so, we had to use the reflexive property of congruence. We had to use the given information, the angle KJL, we had to use that. It is congruent to KJM. We had to use the fact that line JL is congruent to JM. And we also had to use, and there is a shortcut that we're going to use in order to state that we are using this. We're actually going to abbreviate it. Corresponding parts of congruent triangles are congruent. We are going to abbreviate that with a C, P, C, T, C. And you will see this often when people are proving information with in a geometric proof. CPCTC is a shortcut for saying corresponding parts of congruent triangles are congruent. Now, this seems like an incredibly large amount of information kind of being thrown at you. I would ask that you take some time to think through kind of what has happened here. You have two additional problems that I'm going to ask you to tackle in your homework. I believe they are problem number 3 and problem number 5. And take it step by step. First, start with what you know and mark that on the figure. And once you mark that on the figure, then ask yourself, okay, what do I need to prove in order to prove that the conjecture that has been presented to me is correct? This requires some deep thinking. It requires you not to give up and to not like throw up your hands and say, I can't do this. It does require you to dig in and look for the triangle congruence theorems to appear in the figures that you are given.